Okay, this problem, which is out of the practice quiz on page 445, is on coordinate geometry. We haven't looked at any of these yet, but what we're going to do is we're going to use what we know about parallelograms, rectangles, rhombuses, squares, plus what we know from coordinate geometry from a few chapters ago, how to figure slope given 2 points, y2 minus y1 over x2 minus x1, and how to find the distance between points, the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, the quantities in both cases. If you encounter any problems like these on a quiz or a test in this chapter or on the final exam, these two formulas will be provided for you, but you'll need to know how to use them. Okay, so they gave us in the book, they didn't give us the picture, I provided that, the coordinates of 4 points. So I went ahead and plotted those points. I've missed the name of that last point. M, N, P, this must be Q. And if I ask you to plot points and label them, this is what I mean. I put the point, which is -2, 3, that's the 2 to the left and up 3 on the graph. Put a little dot there. And next to it, I've written its name and its coordinates. Okay, that's plotting and labeling a point. And that's what I want from you whenever you have to graph anything. Okay, it can be a little tricky sometimes getting the names outside of the figures, but you can do it. Okay, now in the problem, they say to us that the question is, determine whether this MNPQ is a rhombus, a rectangle, or a square. Now they've only given us 3 choices, a rectangle, a rhombus, and a square. So if we're a little bit smart about this one, we might remember that a rectangle is a parallelogram, a rhombus is a parallelogram, and a square is a parallelogram. So unless the author messed up, we shouldn't have to check to see that the opposite sides are parallel. And we should be able to take that to be a given fact. If I wanted to see if this guy is a rectangle, I could, however, check the slopes. And I'll just check the slopes of MN and PQ. Now let's see what we get for the slope of MN. Okay, y2 minus y1, that's 3 minus a -3. x2 minus x1, that's -2 minus a -5. Okay, that's going to be 6 over a -2 plus 5 is 3. That slope is 2. All right. Let's check the slope here. This is the slope of MN. Let's check the slope of NQ. That'll tell us something about the angle up here. That's what I'm looking for. And if I do that one, I'll work under here so I don't run into my drawing here. Y2 minus y1 is 3 minus -3. X2 minus x1, -2 minus 1. Well, that's 6 over a -3. And that is a -2. So let's just check that guy one more time. And the first one was 3 minus a -3, definitely 6. -2 minus a -5 would be plus 5 would be 3. That's definitely a slope of 2. And then 3 minus a -3 is 6. -2 minus 1 is -3. So here we get these slopes. Now, what this tells me is that this angle up here is definitely not a right angle. It didn't look like one, but I didn't draw this perfectly to scale, so I wanted to check. Now, in order for it to have been a right angle, remember slopes of perpendicular lines are negative reciprocal. So we would know that sort of in our toolbox here, if we have a line with slope A over B, then the slope of any perpendicular line will equal -B over A. It's the opposite reciprocal. we flip it over and change the sign. We changed the sign, but this wasn't the reciprocal. So I know those two are not perpendicular. Well, that tells me that this guy can't be a square, because in order for this to be a square, that has to be a right angle, and those two would have to be perpendicular. So it's definitely not a square. The question is, if it's not a square, is it a, well, and actually it's not a rectangle. Sorry. It's not a rectangle, and if it's not a rectangle, it can't also be a square, because both of them have right angles in the corners. So really we're almost done. I guess we are done. If there's only one right answer and it was multiple choice, this has to be a rhombus. But let's do one other thing to take care of knowing it's a rhombus. A rhombus is the only parallelogram, well, squares also, but they're special rhombi, the only parallelogram with perpendicular diagonals. So if we get the slopes of the diagonals and their opposite reciprocals, the a over b negative b over a trick, then we know that that they're perpendicular. We know that has to be a rhombus. In the context of this problem, if you're on a standardized test and it's multiple choice, you're done. It was the only choice left. So if I find the slope of NP, the slope of NP, well, that's going to be 3 minus a negative 9 over negative 2 minus a negative 2. Well, that's 12 over 0. This guy is undefined. That means it is a vertical line. Now, you run into a little bit of trouble here with the opposite reciprocal, because there's one exception, and that's on vertical lines, which are undefined slope. But we should know that they are always perpendicular to horizontal lines that have 0 slope. So if this has slope 0, we're in, and it will know that they're perpendicular. So let's check the slope of MQ. The slope of NQ is negative 3 minus a negative 3 divided by 1 minus a negative 5. Well, that is in fact 0 over 6, which is 0. So our conclusion then is that NP is perpendicular to NQ. And since I already knew from our previous work, well, from the given in the problem, that there were only 3 choices, so that had to be a parallelogram. If you have a parallelogram with perpendicular diagonals, it has to be a rhombus. So the answer to this question is that this guy is a rhombus. Now, as long as we're talking about this type of problem and not just this problem, if you still had doubts and you wanted to confirm that this really in fact is a rhombus, even though we proved that it is, the last way to take care of it would be to see the lengths of the 4 sides. If all 4 pairs of sides have the same length, which would be using the distance formula 4 times, then you're going to have that your figure is a rhombus by definition. Also, if it were known to be a parallelogram at the beginning, any parallelogram with 2 consecutive congruent sides would have to be a rhombus as well. Okay, I'll do one of these operations. I'll find the length of MN here and leave the others for you to investigate. But just to show the distance formula, the length of MN, which that's what that means, is a big old square root. And it's the square root of negative 2 minus a negative 5 squared, that's the x2 minus x1 squared, plus 3 minus a negative 3 squared. Okay, so that means that MN, the length of MN, is the square root of, well, this is going to be negative 2 plus 5 is 3 squared is 9. And this is going to be 6, and 6 squared is 36. So I'm getting the square root of 45. So if each of these work out to be the square root of 45 in length, and I wouldn't bother simplifying it because all you want to know is that they're all the same thing. So it's easiest to leave that as root 45. And if they're all root 45, then we know it's definitely a rhombus as well. Okay, those will be the tools you'll have to work with on problems like these. Now that we've seen them, they are fair game.